Now let's study the electric potential due to a uniformly charged solid sphere. Say we are given with a solid sphere of radius r, which is uniformly charged in its volume with a positive charge q. Then we can say that as it is uniformly charged, for outside region, whole charge appear to be concentrated at its center. So if we calculate the electric potential at a distance x at an outer point, then we can write for x greater than r, potential at point P can be directly given by the result of a point charge as kq by x. If we talk about a point on surface, then also for at x equals to r, potential at surface we can write as kq by r. Now, if at an interior point we talk about, say this is a point A, then we know that the electric field exists in radially outward direction. Then if we talk about point A and point S, then in the direction of electric field we know potential decreases. Then we can say for x less than r, electric potential at an inside point A will certainly be more than potential on the surface, because in the direction of electric field potential decreases, so VA must always be more than VS. And here we can write using a relation of potential difference. Here we can write VA minus VS is equals to integration of E dot dx that will exist from point A to point S, and we take its magnitude because we know potential at A is more than that as S. And inside electric field we know at a distance x is given by kqx by r cube, which we already studied in the section of electric field inside a solid uniformly charged sphere. We substitute it, you can see we are getting VA minus VS is equals to, here this kq by r cube will be common out, and it will be integration of x dx, which is integrated from x to r, because at point A, if it is located at a distance x, then point S is at a distance r from the center. So here VA minus VS we are getting kq by r cube, and the integration of x will be x square by 2, where we substitute limits from x to r. So the result will be kq by 2r cube, this r square minus x square. So now if we find out the potential at point A, which is an interior point, so Vs can be taken on the other side, it will be kq by 2r cube, r square minus x square plus Vs, which is potential at the surface, we can write as kq by r. So potential at an interior point can be given by kq by 2r cube, 3r square minus x square. On calculation you are getting this. This is the expression we get for potential due to a solid uniformly charged sphere at an interior point. The same can also be plotted as a function of x. Let's continue on the next sheet for the same. Here you can see the potential at an interior point is given by this expression we have just calculated, and at x equals to 0 if we find out, then potential at center, here you can see the result will be 3 by 2 kq by r, this we are getting. And if we just plot the variation of potential with the position in case of a solid uniformly charged sphere, then from x equals to 0 to r, the variation will be given by this expression, and at the surface the potential is kq by r, and at center where x is equals to 0 it is 3 by 2 kq by r. So the curve will look like approximately of this shape, and the outer region it will move on same as if it is that of a metal sphere or a hollow sphere, where V inversely varies with the position. Only in the interior region it will exist in such a shape which will represent this curve. So this is the variation curve of a potential with the position in case of a solid uniformly charged sphere.